Welcome back. Let's talk about geocoding chapter 7. In this chapter we'll talk about geocoding. In this presentation we'll talk about geocoding, its definition, some of the methodologies involved, and then we'll look at some of the common issues and some solutions for those common issues, and then we'll look at some data sources where you can actually create your own address locators, and then we'll talk about polygon geocoding and how to perform all these in ArcMap interface. So geocoding is nothing but a process of creating geometric representations for descriptions of locations. Meaning, if you have street addresses, list of street addresses, let's say for all your students or clients or customers, you need to map them in a geometric or a geographic way. You take those addresses. Using a process called geocoding, you put those addresses on a map. So that process is called geocoding. So essentially it uses a computer program that employs code tables and standardized address components called geocoding engine. There are two ways to geocode in ArcMap. One is batch geocoding, which is essentially saying I have a table of 5,000 addresses, let's just geocode all of them. Or interactive rematching, where you actually go one by one and actually map all these addresses to their exact locations. This is more accurate, but it takes more time to actually process. Geocoding examples, well, I can think of many examples. Businesses trying to map store locations and compare it to competitor locations, and then you can think of it as emergency dispatch operators geocode all the addresses to determine who should respond to an emergency call. Like essentially, if there is a fire station, they'll map all the addresses and sort of like drop their districts based on time it will take them to actually reach each one of these geocoded points. And then business economic development departments trying to map businesses in the downtown areas or something, to see if there are clusters of technology rich areas in the city. These are just some of the examples. Geocoding is very common. One of the main things that you'll take away from this class could be geocoding. So geocoding files, usually it is a tabular data, could be in Excel, could be in DBF, it could be in Oracle, it could be in SQL, it could be in any format, but it is a table of street addresses where you have a neatly formatted address, city, state, zip code columns. It usually makes your life a lot easier if you have these in separate columns. Otherwise you have to clean it up to actually create these 4 fields to have higher accuracy when you geocode this stuff. And you can also have X and Y's or latitudes and longitudes. That could be pretty easy to geocode because we can just use the XY event procedure to actually geocode those kinds of data. So what do we need for geocoding? We need street center lines. So we already seen in part 1 of this week's exercise how Tiger files are formatted. Tiger files, let me show you how the Tiger files are formatted one more time. So physical attributes of Tiger streets. As you can see, each street has a F2 node and from node and the length and left address and right address. So this information is what is extremely critical in actually deciding or in the process of geocoding, because there's something called linear geocoding which we'll see in just a minute. So we need street center lines, and then we need zip code polygons. Perhaps if we are trying to map centroids of zip codes or something. And then other geocoding files could be, you could map railroads, rivers, perhaps if you are trying to map parcels, you can have parcels, census blocks, census tracts. There is, for geocoding files, anything can be geocoded. You can have a bunch of parcel numbers, you can have a bunch of tracks or places is nothing but city names and county names. You can essentially geocode anything, and actually map them in ArcMap. So how do we do this? What is the process behind this? It's called linear geocoding or street geocoding. So urban street maps, especially tiger maps, have 4 street address numbers ranging from low to high on each side of a street segment. So for this, in this example, on Oak Street, one side has even numbers, one side has odd numbers. So the addresses on the let's say on the right hand side are even, and addresses on the left hand side are odd, and then they range from 1 to 198 on the even and 101 to 199 on the odd side. So what happens when we are trying to map an address like 125 East Oak Street 15, with that zip code 15213? So the address becomes parched, which means it when ArcMap is processing this information, it's gonna break it up and it's gonna look at it as 5 different parts: the address number, and then the direction, prefix, the street name, suffix, and then there is the zip code. So street number, house number, street number, street, and zip code. So once you have that, an index value will be generated for each one of these values. So for the street name, it's gonna generate something called a sound index based on how it's sounding, Oak. So based on that, it's gonna identify probable candidates within the database. It's gonna find all these different probable candidates, and it's gonna start ranking them. So candidates will be scored and filtered. So since this is 125, it cannot be between 2 and 199. That's eliminated. 1 to 199, that's eliminated. So it has essentially left with identified two top candidates. One is 100 to 198 and 101 to 199, between which have the highest probability of having the address 125 East Oak Street Drive. And then it's gonna move on to the final step, which is the identifying the best candidate. So based on which side is even or odd, it's gonna map it on that side of the street using something called interpolation. So it's gonna break this side of the street into essentially 50 different little pieces. And then it's gonna count where would be the possible 120. It's gonna calculate based on simple distance where would be the possible 123 number, and it's gonna place it on that street. So again, that's how your address is geocoded. And when you are actually generating a database for geocoding or cleaning up your database, you need to understand all these different aspects. An address component has number, street name, street type, direction suffix, direction prefix, unit number, zone city number, zone zip code number, and for single street addresses, it's gonna look something like this. So you need to consider all this when you're actually geocoding your batch geocoding all your addresses. So we'll see what this means and how this is done in a minute. We'll go back to the walkthrough. We'll switch to ArcView and actually run this geocoding process. So possible problems, as we can easily say, variations in street names could be a problem. In the database, it could be called Fifth Avenue, but here it's called Fifth Ave or Fifth AV, and then there could be variations in it could be Route 51, right? Fifth Avenue could be Route 51, and somebody would say 121, 123 Route 51 at the same time instead of 121 Fifth Avenue. So stuff like that. And then data entry errors, like somebody would misspell fifth, and maybe they're lazy enough, they'll exclude boulevard, which would actually mess up a whole lot of things. Sawmill Run is not a street, so it won't be able to match it. You have to clean that up. And then if you're some of them, instead of actually writing an address, they'll just write the place name or a building name. 10 South Broadway would be called Equitable Building. If they just write Equitable Building, nobody would know where that is, or the system wouldn't know, because there are no alias names in the database that we have. Maybe we can add them. Of course we can add them, but that will take a lot more time than actually fixing the errors in the database itself. Somebody would say Fifth Avenue and Craig Street, so that could work given certain criteria. So there could be several other issues, like it's the zip code is mentioned incorrectly, or the PO box, somebody would just write their PO box number instead of actual address. And there could be missing street information. These streets, you have to get the latest street information, otherwise some of these addresses might not be found, because it could be a new street, or the street was not, the street was recently closed. It could be several different reasons why an address could not be matched in ArcGIS. Some of the solutions, of course, always clean your data before geocoding. Use standard postal addresses. Make sure it is set up like how we talked about street number, street name, with a proper direction prefix and a suffix, and city and state and the zip code and all that good stuff. And then you can use standard intersection connectors like and. Instead of writing A and D, you have to use ampersand and stuff. So there's several different solutions you can use to actually clean up the database. That would be the toughest part. So use alias tables. You have to create tables for aliases, like White House will be 1600 Penn Avenue, and Heinz Field will be 100 Art Rooney Avenue, so on and so forth. And then you have to assign house numbers in rural areas, and then purchase high quality maps, because most of the times the free data can only do so much. So you might want to consider purchasing a good quality street data if you don't have one. Especially if you are working for a large corporation and they're trying to do geocoding on a regular basis, it might be worth your time and effort to actually go ahead and purchase this street data, which is available from ESRI, by the way. Street map sources, the free stuff you can download from Census 2000, Street Center Lines, or maybe even from the Census website, and then you can download them and then build a address locator based on that. And of course you can buy the Street Map USA, which is from ESRI itself, to actually which would have inbuilt street locators and stuff, address locators. And then for a small fee, you can download individual zip code layers from GDT Dynamap, which is very accurate. So let's look at some of the stuff before we move on to polygon geocoding. Okay, I do want to finish polygon geocoding before we actually move on to the walkthrough. So polygon geocoding is nothing but it's a method for mapping data whose identifier is a polygon, like a zip code polygons, or city polygon, or county polygon, or place polygon, or a census tract polygon. So what you do is you create an aggregate table with a single record for each polygon, and then essentially count the records for each polygon by joining to the corresponding polygon layer, and then symbolize with choropleth map or graduated points, which we'll see how to do this. And then you can obviously download the zip code file from Tiger, Census Tiger files. You can download all these polygon topologies like American Indian reservations, Alaska, village statistical areas, and all these different statistical areas. and FIPS state and county codes, and places and census tracts, census block groups and blocks, and all that good stuff. And then actually create or geocode those individual pieces of data. If you have a bunch of census tracts, you can geocode them. If you have a bunch of Alaskan nature regional corps, you can do that. So let's look at how to do it for zip codes, how to geocode zip codes based on using polygon geocoding. So essentially you have the zip code file. What you do is when you actually geocode at polygons, it's gonna create a zip code centroid file. When that happens, what you can essentially take those centroids and join those centroids to the actual zip codes. And when you do that, we have done this before, this is spatial joining. When you do that, when you click on sum, it essentially is going to give you a number of points within each zip code, or number of geocoded points within each zip code, which will tell you a lot of information. Let's assume this is essentially attendees for like a conference for in Pennsylvania. Okay, you map the zip codes of all the individual attendees and create a centroid file for them, and you join them to the actual zip code polygons, and then you get a sum of attendees per zip code, and then you can actually create an attendees by zip code map, which would be a lot useful for you in visualizing where are your prime attendees coming from. Where is your prime base or primary market area. Geocoding an arc map. Let's see a brief overview. What we need, the first step is to actually create an address locator based on it could be addresses or polygons or anything, but you still need an address locator. And then you choose the reference layer to actually create this address locator, and then you add the tabular data and streets layer and add the address locator. We'll see all this in action, which would be a lot more useful than actually talking about it. And then you have to eventually address rematching. We have to do the address rematching, and then prepare a log file on what did work and what did not work, so that it could be used by somebody or yourself in cleaning up the addresses a little later, or maybe perhaps as part of your cleaning up the databases. Okay, and then there are useful websites. You can look it up in the slides. You can go to those websites to actually do some of this geocoding, especially badgeocode.com. You can geocode up to 250 addresses without actually doing much of the work. It's very useful. I use that a lot. And let's jump right into the walkthrough. So geocoding. Let's open up our books and go to chapter 7, which is geocoding. The first step is to actually map looks like we're working with an organization called Flux, and the planners of Flux would like to know where their attendees are coming from. So looks like this is an arts organization based in Pittsburgh, and the first part we'll match them to their zip codes, and then we will match the actual addresses. So let's get with the zip code mapping, the zip code centroid mapping. We will open the Pennsylvania zip code map, which is 7.1. So let's get started with tutorial 7.1, geocode data by zip code. So we already know geocoding to zip codes is a common practice for many organizations, because most of the people don't like to give out their actual addresses. They would be happy to give out like a zip code. So it is a pretty good and a very common measure to actually map your customers or your clients sort of a thing, without sort of invading their privacy at the same time.
So it is a very common practice for most organizations to actually map geocodes instead of actually the actual you know subject address, so to speak. Anyways, in this example, we'll be looking at mapping the attendees of an art event sponsored by this organization called Flux, and they would like to see where the people or the attendees are coming from so that they can plan their future market activities. So the first step we need to do is to open the map document, which is 7.1. So looks like all the zip codes in Pennsylvania. Let me look at this list by source tab where I have the attendees file. Looks like I got the addresses, although we are interested in mapping just the zip codes at this point. Okay. Let's see. The next step here is to open the attribute table, and then what I want to do is show you that the state has the attendees are from not just this state. They are from California, Florida, Ohio, and most of them are from Pennsylvania, and some from Texas and South Carolina. So what I want, and some of them did not give out any address. So the maximum number of addresses we could possibly match is by, since we are only mapping the Pennsylvania zip codes, we can do by select by attributes and state is equal to Pennsylvania. So I got 1124 matches, which means that's the maximum number of records that we could match today, because all these attendees are from Pennsylvania, and we have data for Pennsylvania. So I'm going to close this. I'm going to clear the selection, and I'm going to close this table. And now let's get to work. Create an address locator for these zip codes. How do we do that? So what we need to do is go to catalog, and then go to my exercises, and go to chapter 7, and in the address locator what we need to do in chapter 7 is right click and say new address locator. Right here you click on that, and then for the address locator style we select US zip 5-digit zip code and click OK, and the reference data is going to be the PA data, which is under ESRI press GIST1 data, United States GDB, and PA zip codes, PA zip. So you select that, click on add, and scroll down, and then the output is going to be, it's going to be called PA zip create address locator zip codes. Just going to call it PA zip codes, and then we're going to go with the default options for now and click on OK. So the address locator will be created. So we are essentially saying, okay, we are creating a address locator for just like a 5-digit zip code, and now my address locator is complete. So I'm going to go back to my map, and I'm going to click on geocode addresses, and here I'm going to add my I'm going to click on add choose an address locator. I'm going to go actually browse to my exercises chapter 7 and the PA zip code. So I'm going to add that to the map. And also what I would like to do, you can also do this from the geocoding toolbar, which is available right here. You can actually use map extent, manage your address locators. Again, you can access the same window from this location also. So I'm going to select that. I'm going to type in a zip code that I know. Let's see how this works. So this zip code is 16313. Okay, type an address 16313. You see what it just did? It is finding the centroid of that particular zip code. Let's look at something else. So that's Pittsburgh 15. Let's just copy that. You see, it's finding the centroid of the zip code we want it to find. So that's how an address locator works. So now that I know this thing is working, what I want to do is actually put this to work. Right click and I'm going to click on geocode addresses, and then I'm going to use the PA zip codes. I'll click on OK. Attendees table zip code field is called zip_code. I'm going to select that, and then I'm going to save this in my chapter 7 as a under the I want to save this into the geo database. So under the geocoding, I'm going to save this as a attendees zips, and I'm going to click on OK and see what happens. So essentially it is saying 176, which is 14%, could not be matched, but we already know I could only match a maximum of 1100 something, which means I'm only missing out on less than 100 zip codes that could potentially match with the data I got, which is only the data for Pennsylvania. So I'm gonna click on close for now and see, look at the data. I'm gonna click on one of these points here, and let me actually click on some of these more city zip codes. As you can see, this zip code has almost 20. 1, 2, 3, 4, 5, 6. These are different attendees coming from the same zip code. So the point of mapping zip codes is that we'll get this kind of information, because what we want to do eventually is count the number of attendees coming from each zip code. So it's not really doing that. What it has done is place all these people or all these points within the same zip code. So the next time we spatial join the polygons to the points, it will essentially count them, count all these 20, all these multiple. It looks like we identified 70 features. I'm sorry, not 20. Looks like we got 70 different attendees. Let's look at some. And I got 46 here, and I got 4 features. You can see how many features we identified at the bottom of the identify window. So we would like to actually attach this information back to the polygon file, the zip code file, and I would like to create some thematic mapping for the marketing team so that they can do their marketing magic, I guess. So let's count the geocoded records by zip codes. What we can do is let's look at the geocoding results. It's safe to say, and I would like to say select by attributes, and then so well, we know how many have matched, so I'm not going to do that. What I will do is right click on matching address, and I'm going to click on summarize, and then I'm going to select, and then I'm going to save this table under geocoding GDB, and I'm going to call this as count. So let's see what happens when we do this summarize, use the summarize function. Let's add that map to the add the table to the map and open that table. So as you can see, 176 of the total number of attendees were not mapped, but the rest of them have been mapped. Let's see what's the total of the rest of the. I'm gonna right click and click on statistics. As you can see, 1089 zip codes have been mapped, which is good news for us, because, and then the best part is it is counting the number of attendees within each of these zip codes. So essentially this is the table we need to actually create some kind of a thematic map. We can either join it to the PS zip codes, or we can actually join it to the geocoding results, and then creates a sort of like symbolize these zip codes by point size sort of a thing. So it says why don't you actually join the attribute table to get attendee zip. It is asking us to join to the geocoding result again, so I'm gonna right click and click on join. So we are joining this summary table back to the geocoded zip codes or the point file. I'm gonna click on join, select zip, and I'm gonna select count table, and yes, matching addresses where I have the zip code. I'm gonna click on validate join. So 1265 records have been matched. Excellent. I'm going to click on OK. So now I'm going to go back and click on properties. I'm going to go to quantities, graduated symbols based on count of matching address. You can select any symbol you want. Essentially, I'm going to go with a simple green or like a blue or a red or a green. It's up to you. I don't really worry about the colors too much right now. And then do maybe a quantile breakdown and 5 6, it doesn't matter. Okay, so when I zoom out, as you can see, I clearly know that most of the attendees are from within the I would want to say Pittsburgh area. So that's how you actually use geocoding to create some thematic maps to make sense of the data we got. So that's just one of the examples you can that's just one of the ways you can do this. Another way you can probably join is to the PA zip codes itself. You can join the same table based on zip code, count, matching address, and then perhaps use the same graduated colors by but by doing this, what you're doing is eliminating all the ones which are 0, which is also good because I can probably create a copy of the same layer, and then one of the copies could just be a feature layer with like a hollow outline, so that now I can see what layers a layer of zip codes by their total counts. You can see some of the red zip codes right here. Most of these zip codes which are close to, which are within Pittsburgh, have more attendees coming from them because of the proximity. So the marketing team can have a marketing plan for these areas, and they can. This is very useful information. So again, that's how you actually use the data, the geocode by zip codes functionality, to create a couple of maps, couple of graphics into a meaningful and feed it to a meaningful decision making process. And let's fix the next step is to fix and rematch zip codes. Let's see how that's done. What I'm going to do is I'm gonna click on this and I'm gonna click on review and rematch tool from the geocoding toolbar. I'm gonna click on that. So now I got all the zip codes, which all the matching results essentially. So when I say I want to look at some of the unmatched results, so if I put this by descending order perhaps, so most of these doesn't have any, perhaps these are outside the state. But the book is asking us to geocode or find the ones with object ID 50. So I'm gonna scroll up and find it. So it looks like this one. So let's examine what's going on here. So this is within Pittsburgh City. So what we need to do is find a zip code for this 11244 Azalea Drive in Pittsburgh. So let's see what zip code it belongs to within I don't know, using Google Maps, I guess. So I'm going to go back to my maps, click on maps.google.com and type in that address. So I'm gonna type in that address and click on enter. So looks like that's the address for it, and the zip code is 15235. I'm gonna copy that and come back to my map document and paste that zip code here and see if I got a match. Yes, I have a match. So I'm gonna click on that and select match. So now the status of this has been changed to match from unmatched. So the best way for you to actually do this is by perhaps sorting this by state, or maybe like a city name, or I would actually do it by state and make sure everything that has PA. Let's look at this 1200 Pond Street, Bristol, PA. So Pond Street. So this has a zip code of 19007. I'm going to type in that address. So I found a match. I'm going to click on match. So again, these are missing zip codes. You have to find the ones with missing zip codes and essentially say, okay, give me, I'm going to try and fix them because those needs to be fixed, because they have an address and they belong in PA, and we are really interested in what happens in PA, which is Pennsylvania, right? So we need to try and fix them interactively. So that's how you interactively match, rematch addresses and complete or fix all the errors you have using Google Maps, a combination of Google Maps or Bing Maps or whatever you are comfortable with in conjunction with ArcGIS. So let's close this. I'll let you play with it, and if you want to match and play with the rest of the addresses, that's up to you. But I'm gonna move on to 7.2. Open. I'm not going to save my changes. So now we are going to geocode data by street address. Till now we mapped the flux attendee records by zip code, but this time we want at street level for Pittsburgh City itself. So what we need to do is sort of examine what the data we have in this map document. We have again attendees, streets, and we have neighborhoods, right? What we need to do is, you'll find that, let's open the PGH streets. As you can see, you have F node, 2 node, left, right, length, and left address, right address, all this good stuff. Looks like this is Tiger data, which is good for us because Tiger data, as we know, can be used to actually create address locators, and using those we can actually map actual addresses. So what the first step we need to do is close this, go back to our catalog, and I'm going to create another address locator. We can create this address locator right here. Oh, actually we have to create this address locator within the GDB itself. We can create it anywhere, but let's create this within the GDB. Address locator style is going to be US dual ranges, US address dual ranges. Click on OK, and then the reference data will be the CBD streets. Is it? No, it is within my exercises data. Let's click on so let's go to our Pittsburgh folder within the data, and within the city GDB we'll have the PGH streets. I'm going to select that, and then I'm going to scroll down and actually change the name as PGH streets. We don't need anything else. And then as you can see, some of these fields have asterisk, like sort of like a star symbol next to them, which means those are required right to. So unless these are automatically mapped for you because this is a standard Tiger file, otherwise these things you have to match them interactively, just like I did. So anyways, I'm going to click on OK. So once that address locator is created, we'll examine that and see what's going on with that address locator. So it's gonna maybe take just like a minute. So here it is. I'm going to double click on it. As you can see, there are reference data tables, and then there are you can add like a alias table, perhaps for building names or landmark names and stuff like that, and then input address fields and outputs and geocoding options and so on and so forth. As you can see, there is like a minimum score of matching. You can change all this. You can change all these options. So obviously you can change the spelling sensitivity, and there is like intersection connectors. Like now you can actually add intersection connectors like and at, so that you get better matches. And then you can obviously have like a side offset, because offset is important. Even if it can't find the right address, it can essentially try to find the closest possible one, which is a good thing, especially when you're working with bigger databases. So these are all the options you need to be aware of what the address locator will be doing. So this might be slightly different from what you are used to seeing. The book might have a different interface, but don't worry about it. This is the new interface and we are okay with it. So it's just a different way of showing the same data that the book is trying to show. They changed, they slightly upgraded this software, and some of the things changed, so they might not look exactly like this, like the ones in the book, because the book is written in 2009 perhaps, or 10. Anyways, let's add this address locator. I'm gonna manage my addresses. I'm gonna add an address locator which is within my exercise folder, not my assignments, exercise chapter. Add my zip codes. Add my streets address locator. Then I'm gonna click on close. So let's try to find an address. So I'm gonna click on the find button, and I'm gonna say let's find this within the PGH streets, and I'm gonna type in an address 3609 Penn Avenue and click on find. Oh, actually, so let's try and find this address 3609 360. Actually, you need to go to locations tab and select the PGH streets, or you can browse to it, but I'm gonna type in 3609 Penn Ave 15201. What the book doesn't tell you is to type in the zip code. If you don't type in the zip code, you're not gonna find it. Trust me, I tried it. So you see a little green dot appear on the map. That's your address that you should be finding. I'm going to right click on it and say add point. Actually, let's make it add label point, and we're gonna find 4 more addresses like 255 Atwood Street, 15213. Add label point, and then you're gonna find 1920 South 18th Street. You see, you have to type in the zip code, which is 15203, and then right click and say add label point, and then the last one is 3527 Beechwood Boulevard. Again, it's 15217. So that's how you find your addresses and add them to the map, like interactively mapping them. And let's map these geocoded these attendees to the map. Let's geocode these addresses. I'm gonna select PGH streets, and in the zip code I'm gonna select zip code, and for the address I'm gonna select address. I'm gonna save them in my as attendees streets, and I'll click on geocoding options right here and make sure it looks exactly like the book. Minimum candidate score, I'm not gonna have pretty high standards. I'm gonna go with a minimum of 10, and then I'm gonna make sure everything looks the same and click on OK. Let's see how many how many addresses have been mapped. Matched addresses 545, I got 550, and unmatched are more or less 720. So that's okay. I'm going to click on close. So I got all the addresses I could possibly get with automatic geocoding. So looks like most of these attendees are coming from about 15 to 20 neighborhoods instead of all the 92 neighborhoods in Pittsburgh. You can possibly make that visual observation. So again, if you want to interactively match these addresses, click on each one of them and see why it's not mapped. This actually belongs to, actually that's matched. So you have to keep looking at individual addresses and look at why they have not been matched, and maybe go back to Google and map the addresses. I'm not gonna do that because it's not required by the exercise right now. I'm gonna go to 7.3. So what we need to do here is, so let's actually interactively rematch some of these addresses. I'm gonna click on interactive rematch. I'm gonna scroll to address, and I'm gonna put them in ascending order. So if there is no address, there is no point matching them. So scroll to 1011 Brady Street. So again, as you can see, this address is very similar to the ones above. This is not matched because it has a missing zip code. So what we need to do is add a zip code to it, which actually we know from the previous address it's 15203. Essentially, I'm just going to come down here and type in 15203 and find that address, click on that and say match, and now that address has been matched. So stuff like that, you have to interactively match them by pointing to the map. But we can so another type of matching we can do is by pointing on a map. So let's see how to do that. I'm gonna sort this data by object ID and scroll down to object ID 826. Let's see, 826. Well, it's not the same as the book. So I found another address which is actually just zip code 15221. So for me, that's record 1015. I essentially arranged these addresses by zip code and found 15221, which doesn't have any other values except zip code. So let's assume in a hypothetical case we know where this guy actually is. We know this guy that maybe in the survey or something, or maybe in a phone conversation, this attendee said I live on Canada Way. So what we do is we know where Canada Way is. Which is right here. So we decided that we want to map him somewhere in the middle of the street so that we place him roughly in the same neighborhood at least. So that's a decision we made. So I'm gonna say pick address from map, and I'm gonna make sure that I'm on Canada Way. That's Canada Way. So I'm going to pick address from the map and click on so 15 we'll close that for that. So since this is Canada Way, I'm gonna pick somewhere in the middle and right click here and say pick address. So essentially it is picking up an address there, and you see the status has changed to match, and it actually matched up with that address, so it added a point for that. So now that's how you actually rematch an address using pick address from the map. So by interactively zooming in, zooming out of a map and maybe placing these points individually. So that's 7.3. Moving on to 7.4, what we need to do is essentially save this work, perhaps open 7.4. Now let's in this exercise we're gonna correct street reference layer addresses. So we'll learn how to fix an incorrect address in a reference street layer used for geocoding. So let's look at the data here. So we have a clients list of clients database. Looks like some of these have some kind of like a place location. Anyways, we'll come back to that. And then we have CBD streets and SCBD outline, central business district. So let's create an address locator for CBD streets. I'm going to go back to my address locator our catalog. I'm gonna I'm going to right click and right click within the geo database, and I'm going to say new address locator, and I'm going to select US dual range as we already did before. And here for the addresses I'm going to select I'm going to scroll to my data, and within the Pittsburgh folder there is Central Business District GDB, in which I have the CBD streets. I'm going to select that for the reference data, and then I'm going to call these PGH CBD streets, PGH CBD streets, and then I'm going to click on OK. So what we need to do now is geocode addresses to the CBD streets. So now that the address locator is created, I'm going to scroll down and say manage addresses. On the geocoding toolbar I'm going to click on add, and I'm going to go to my exercises chapter 7 geocoding GDB, in which I have my CBD streets address locator. I'm going to use that. Here I'm going to right click on the clients. I'm going to click on geocode addresses, use my address locator that I just created, click on OK. Addresses and zip, that's correct. So I'm going to save this as CBD clients, and then I'm going to go with the default options. I'm going to click on OK and see that only 15 matched and I have 12 unmatches. This is unacceptable because I have 56% unmatched addresses, which is quite a lot. So let's look at what's going on here. Click on the CBD clients in the table of contents. Close this, and then let's look at what's going on. And I'm gonna scroll to the right and go to address and put them in an ascending order, and then scroll down to 490 Penn Avenue. So 490 Penn Avenue, you would think should have a match, right? Apparently it doesn't. There are many candidates. So here the issue seems to be we have pretty high standards for matching addresses, so I'm gonna have to adjust that. I'm gonna say minimum score of 10. So now I see that I have a bunch of matches. The 490 is closest. The closest one I could find is 500. So I'm gonna click on that, and I'm going to click on zoom to candidates. So I want to look at what's going on. So if I, so looks like that's the 500, the highlighted one, which is the first one, is the 500, and then 526 is that one. You know, it keeps going up. So 500 is that one, obviously. So I'm going to examine the street that's right next to it. So since these are increasing addresses, our address should be somewhere here. So I'm going to select this street here, and I'm going to close the interactive rematch window and open the CBD streets table of contents, and then look at that selected record, and looks like there is no there are no values for the left to and right from and right to. So that is an issue. Suppose that you have obtained valid numbers for the street segment missing attributes 498 to 474 on the left side and 499 to 470 from on the right side. You need to edit this table and rebuild your address locator so that most of these addresses would rematch. So what we are gonna do is start editing this table. Start editing. I'm gonna, for the left LF add going to be 498. LT add is going to be 474, and then RF add would be 499, and RT add would be 475. So once I have those, I'm gonna say editor, save edits, editor, stop editing, and then I'm going to close this. First, even if we try to rematch this, it's not going to work because the address locator is still based on the old data, the unedited data. So I'm going to go back to the our catalog, and I'm going to click on rebuild. So once I do that, it's essentially going to consider all the edits that we make in the street network. And now when I try to find essentially when I click on CBD clients, and I'm going to review rematch addresses, and I'm going to scroll to my address field, sort that in an ascending order, and scroll down to my 490 Penn Avenue, and the geocoding options again. I'm going to add 10. So first what we need to do is manage address locators. I'm going to remove my existing CBD streets, and now I'm going to re-add that to the map document just to sort of like give it a good refresh, and then add it back. And now I'm going to close this. I'm going to click on my CBD clients, click on rematch addresses, and then I'm going to scroll to my address field, sort it in an ascending order, click my Penn Avenue. Now I see I already have a perfect match, 100. So I'm going to click on match, and I'm going to close. I'm going to save my work, and then move on to tutorial 75. That's how you actually fix the issues with the street network and fix the street network itself. So the next step is to actually use an alias table. So what we need to do is click on add button and click on Central Business District GDB. I'm gonna go back to my data folder. Under Pittsburgh, there is a CBD GDB in which there is a building alias names. I'm gonna click on add, and then I'm gonna examine that because it has, as you know, it has some of these place things we talked about. These are essentially building names, and it has address and zip code. corresponding to those landmarks or building names. And now what I'm going to do is click on my CBD clients rematch addresses, and now I'm going to click on geocoding options. I'm going to add my alias place name, alias table. I'm gonna alias field is building name, obviously, and I'm gonna click OK, and then the next step is to scroll down the addresses we have and find the 2 gateway center. Perhaps now I have a perfect match. I'm gonna match that. 1 PGG, I'm gonna match that. I'm gonna match all this stuff because now I know, because these were not, you were not able to match these before because we didn't have an alias table. Now we do. So that's how you actually use an alias table to improve your matching accuracy. Now we are up at 37%, which is acceptable. Maybe we can work on it some more. So anyways, that's how you actually do geocoding. Good luck with your assignments.